Good morning students. Welcome to our online video class of chemistry. Today we are going to start new chapter unit 3 electrochemistry. Electrochemistry is the branch of chemistry. In electrochemistry we study reactions which produce electricity and other chemical reactions which take place with the help of electricity. The first type of reaction occurs spontaneously, but the second type of reaction are forced to occur and work is done on the system. What is electrochemistry? It is the branch of chemistry. Electrochemistry is the study of production of electricity from energy released during spontaneous chemical reactions and the use of electrical energy to bring about non-spontaneous chemical transformation. Why we are studying electrochemistry? What are the importance of electrochemistry? Chemistry is important in both theoretical and practical consideration. The electrical energy and the chemical reaction are correlated. Both are redox reaction in nature. The container or vessel in which these changes were carried out or studied is known as cell. These are of two types, namely electrolytic and electrochemical cells. And in an electrolytic cell, the chemical reaction is non-spontaneous in nature. And the main difference between electrochemical cell and electrolytic cell are electrochemical cell is the device in which electric energy is formed from chemical energy. And electrolytic cell, it is the device in which electric energy is consumed to bring about chemical reaction. And many reactive metals such as sodium, potassium, calcium, aluminium and other large number of compounds such as sodium hydroxide, sodium carbonate, sodium bicarbonate, etc. are produced as a result of chemical reaction which take place in electrolytic cell. The fuel cells and batteries which convert chemical energy into electrical energy, which is used on very large scale in instruments and other devices. The reactions carried out electrochemically can be energy efficient and less polluting. Therefore, study of electrochemistry is important for creating new technologies that are eco-friendly. Electrochemistry is therefore a very vast and interdisciplinary subject. In this unit, we will cover only some of its important elementary aspects. Let's recollect some important topics that you had already learned from your lower classes. What is oxidation and reduction reaction? Oxidation and reduction can be studied in terms of transfer of electrons. According to electronic concept, what is oxidation? Oxidation is the process in which an atom or ion loses one or more electrons. Losing of electrons is called oxidation. Then the species, that is atom or ion, which lose electron during the oxidation are called reducing agent. Let us look at an example. Sodium. Sodium undergo oxidation. It loses one electron. Sodium on oxidation gives Na plus by the losing of an electron. Then sodium here is reducing agent. Another example is iron. Fe2 plus on oxidation lose an electron and become Fe3 plus ion. during the loss of electrons, there is an increase in the positive valency or decrease negative valency of the species occurs. In the case of Fe2+, what will happen? Its oxidation state increases by 1 unit. Fe2+ become Fe3+. That is increase in positive valency. Then let us look at another example for decrease in negative valency. MnO4 2- on oxidation become MnO4-. And reduction is the process in which an atom or ion gains one or more electrons. As a result, increasing negative valency or decreasing positive valency will occur. For an example, chlorine undergo reduction. That means chlorine gain an electron and become Cl- ion. Here an increase in negative charge occurs. And in the case of FeCN6 3-, ferricyanide ion gain an electron and becomes FeCN6 4-. Here also an increase in negative charge occur. And Sn4+ plus 2E- gives Sn2+. Here Sn4+ gains 2 electrons and become Sn2+. Decreasing positive charge occurs in this case. Then in the case of reduction, the species which gains the electron during the reaction are oxidizing agent. In the case of this example, which is the oxidizing agent? Sn4+, because it gains electron. Daniell cell is a well-known example for electrochemical cell or galvanic cell. It consists of zinc rod which dipped in zinc sulfate solution and a copper rod which dipped in copper sulfate solution. These rods act as electrodes and they are connected by conducting wire. The two solutions are connected by salt bridge. An inverted U-tube containing an inert electrolyte like potassium nitrate or ammonium nitrate. When the circuit is completed, it is observed that electric current flow through the electric circuit. In Daniell cell, electrons flow from zinc electrode to copper electrons to external circuit. And the working of the cell is zinc undergoes oxidation to form Zn2+ ion and go into solution. The reaction is Zn gives Zn2+ plus 2E-. The Zn undergoes oxidation by the losing of 2 electrons and form Zn2+. And the electrons so produced at the electrodes are pushed through the conducting wire to copper electrode. And Cu2+ ion present in the solution move towards the copper rod and receive the electrons to get reduced to copper atoms. The copper gets deposited at the copper rod and the reaction is copper 2+ ion gains 2 electrons, gives copper atom, and the overall reaction is Zn plus Cu2+ gives Zn2+ plus Cu. As the electrons flow from zinc, it acts as negative terminal and copper acts as positive terminal of the cell. The electrode at which oxidation take place is anode, and the electrode at which reduction take place is cathode. Salt bridge. What is salt bridge? What is a salt bridge? We have seen in above experiment about salt bridge. Now we are going to study about salt bridge. Salt bridge. Salt bridge is a inverted U-shaped glass tube. It contains in it a thick paste of suitable salt made in agar-agar. For this, agar-agar is dissolved in hot aqueous solution of the salt and is then filled in U-shaped glass tube. On cooling, agar-agar sets into a semi-solid mass or paste. An inert electrolyte is one whose ions do not take part in the redox reactions and also do not react with the electrolyte present in the half cells. Functions of salt bridge. A salt bridge completes the inner cell circuit. The two metal electrodes, as pointed earlier, are connected with the help of wire. But the two electrolytes in their respective half cells are connected by salt bridge. We have seen that the two electrodes, zinc electrode and copper electrode, which are connected through wires. But the electrolytic solutions, copper sulfate solution and zinc sulfate solution, which are connected by using salt bridge. Thus a salt bridge completes the inner circuit. Next function is it maintains the electrical neutrality of the solution in the half cell. In the case of zinc copper cell, the anode contains excess positive charge as Zn2 plus ion and the cathode contains excess negative charge as SO4 2 minus ion. This prevents the flow of electrons from zinc to copper electrode. After some time, when the salt bridge is used, it restores the electrical neutrality of the solution in the two compartments. The anions of the electrolyte used in the salt bridge, for example, chloride ion in the case of KCl, migrates to the anode compartment, and the cation K plus in the case of KCl migrates to the cathode compartment, making the respective solution neutral. Thus, electron transfer is restored and current is produced in the cell. We have studied that Daniell cell converts the chemical energy liberated during the redox reaction to electrical energy and has an electrical potential equal to 1.1 volt. When the concentration of Zn2 plus and Cu2 plus ions is unity, such a device is called galvanic or voltaic cell. If we increase external voltage more than 1.10 volts, the reaction takes place in opposite direction. That is, the cell functions like electrolytic cell. And the picture shows if the external voltage is less than 1.1 volts, then electrons flow from zinc rod to copper rod. Hence, current flows from copper to zinc. Zinc dissolves at anode and when the external voltage is 1.1 volts, no flow of electrons or current take place through the circuit and also no chemical reaction take place. That is shown in the picture. And if external voltage is greater than 1.1 volts, electrons flow from copper to zinc and current flows from zinc to copper. Zinc is deposited at the zinc electrode and copper dissolves at copper electrode.